All right, now doing that same example geometrically, it's the same setup. So I'm going to skip a couple steps here. So here's my object. I already know the force is going to be 50 newtons. So that's calculated the same. This is my vector T1. This is my vector T2. Now I'm going to superimpose a XY axis on here, just like that. And I know that this angle will be 60 degrees, and I know this angle will be 45 degrees. And again, that comes from the Z patterns with the horizontal. Same thing over here. So that's how I got the 60 and 45. Now, underneath, I know that if I take vector T1 plus vector T2 plus my force vector, it's going to equal the zero vector. So there we are right there. So we go ahead and solve. So I'll set it up just like that. So we don't know the magnitude of T1, so I'll leave it like that. And it's the cos of the angle, so cos 60i plus, so again, both components for T1 will be positive because it's across and up. So magnitude of T1 sine 60j. T2, which I'm adding, will equal magnitude of T2, so we don't know that one. And this one's going to be cos 45i plus magnitude of T2 sine 45j plus the force vector. And because it's straight down, it is no I component or no x-axis. And negative, so I should have subtraction because it's going down, minus 50 minus 50j. And when I add that up, I know it's going to add up to my zero vector, so 0i plus 0j. So my unknowns are up above. So when I look at it in terms of the x component. So I'm just going to add up or write the equation for this one right here, this column, just my eyes. So that would mean I would have magnitude of T1 cos 60 plus magnitude of T2 cos 45 plus 0. Oops, I don't need my eyes anymore. Oops. And where did we go here? 1 second. Sorry about that. Things went a little freaky for me there for a second. And I was saying I don't need eyes anymore. So when I'm adding up that x column, plus 0 equals 0. So I got one equation, two unknowns. So I'm going to isolate. Doesn't matter which one you pick, but I know T1 will equal negative magnitude of T2 cos 45. So I moved it to the other side, divided by cos 60. So I'm just going to put a red bubble. This isn't a final answer, but it's one part of the answer. The next step then is to add up the y component. Y component. So I'd have magnitude of T1 sine 60 plus magnitude of T2 sine 45 minus 50 equals 0. So now I'm going to clean this equation up, and what I'm going to do, I'm going to replace T1 with the value here. So now it becomes negative magnitude of T2 cos 45, so I'm just doing the substitution at this point, cos 60 multiplied by sine 60 plus magnitude of T2 sine 45, and I'll move that 50. I'm going to add 50 to both sides. I'm going to factor out the magnitude of T2, and what I'm left with is cos 45 sine 60. And what I'm going to do, remember from grade 11 and grade 12 courses, I have sine 60 over cos 60, so that's just tan 60. So I'm going to have cos 45 tan 60 plus sine 45 equals 50. Final step then, and it should be a negative in there. Magnitude of T2 will equal 50 divided by negative cos 45 tan 60 plus sine 45. That's measured in newtons. So there's the final answer. And T1, magnitude of T1 will equal, going back up to that substitution, it'll be the cos 45 over cos 60. So negative cos 45 over cos 60 multiplied by the value of T2. So that's 50 over negative cos 45 tan 60. So on one hand, I convince you that algebraic method's the way to go. Then the next example, I have people saying, you got to be kidding me. And this is where you need to use your thinking skills and decide which method is best. Because again, there's no formula for this. I can't say you should always use this method. In this case, algebraic method's definitely a little bit longer. It still works. I still have people that use it, so it's not uncommon, but there's a little bit more algebra involved with it, as above. All right. So moving on to the next example. Chris and Josh are pulling a sled as shown. If Josh is pulling with 70 newtons of force, determine with what force Chris must exert so that the sled is traveling a straight line. So we are looking for the magnitude of this vector, and we know that the resultant vector is going to be straight ahead because it's indicated that it's got to be traveling in a straight line. So there's the resultant. So we want to know, and again, we know that the 70 newtons, so how about I do it like this to keep it sort of on par. Here's my u vector, my v, and my r. So I want to find u plus v such that my resultant is r. So in this situation, completely up to you as to how you approach it. I think I'll do this one algebraically. If you do it geometrically, it's probably the same amount of work in this case. So my u vector would be 70 cos 30 in the I direction. So again, when I'm drawing this, here's my origin is right here because all the vectors, tails are there. Positive x, positive y. So plus 70 sine 30 j plus my v vector is equal to x. And if I look at my components, positive x, negative y. So x cos 50i minus x sine 50j. When I add those vectors together, I get a resultant that's equal to, and my resultant vector is along the x-axis. I don't know the magnitude of the resultant vector. It's all on the x-axis though, so it's the magnitude of my resultant in the I, and there's no j component. So again, the goal here is to solve for x. We want to solve for x. That is the whole goal here. When I look at my columns, if I look at my x components, I see that I have two unknowns. I have an x and a magnitude of a resultant. So that's not good. But if I look at the y, I have only one unknown, and that's the x. So I can therefore solve this question by simply looking at the y component. So I would have 70 sine 30 minus x sine 50, and it's going to equal a magnitude of 0. Rearranging, 70 sine 30 equals x sine 50. X equals 70 sine 30 divided by sine 50. And that's newtons. And again, no calculator. There's the final answer. And we're done because we found the value of x. So in this case, all of a sudden the algebraic method doesn't look so bad. And the geometric method would have worked just fine as well. So therefore, who are we looking at? Chris must pull with, oops, with 70 sine 30 over sine 50 newtons. All right. Now to do it geometrically would have been a little trickier, because you would have been looking for the u vector, rearranging it, plus the v vector. Oops. I'm just going to draw my resultant in, because it's horizontal. There's my v vector. I would have known that's 30 degrees. I would have known that this angle up here is a 50. So that means that angle there, well, I'll help you out a bit here. So that would have been 50, and this angle would have been 30 degrees. So that means that the internal angle would have been 100, which makes the other angle 50 degrees. And you know the magnitude of V, so you would have just used sine law in order to find, or sorry, you don't know the magnitude of V, you know the magnitude of U. So you would have just used sine law, so the V vector. So you knew this information and you knew all three angles. So you would have been just using sine law once and you would have got to the same conclusion. So again, both processes in this case equal amount of work. All right, so please don't lock yourself into one mode of thinking. So I've left, in the next slide, and you'll see this one, if you've printed out the note already, I've left that available. So you can go ahead and try that geometrically using the triangle method if you want, just to show yourself that it does work out. So I'll leave that for you to try on your own. So we're going to pick this up in the final topic here. I'm going to move to velocity as a vector in the next video.